Okay, good morning, and it's a pleasure to be here with you early in the morning here in Spain, and sharing with you all these experiences. Also, I'm very happy to have seen this first talk, which is very much in line to what I'm describing here. I'm trying to follow a little bit the process we've been doing with different companies, and also working with different colleagues in the university, but also outside through this association that we have, which is really non-profit association located at the University of Seville. The name is Ingeman, and we normally have a set of companies, partners, and we do work extensively here in Spain with them, but also in many other countries around Europe, and especially South and Central America, also some companies in North America. So we very much living this process of digitalization, digital transformation, and very much willing somehow to share our experience with people like you that are in this world of reliability and maintenance. My idea is talk a little bit about the strategy setting process, because definitely we're talking about a strategy. So we're trying to somehow give some clues about what to do first, what to do next, what should be the different movements to do in order to reach a certain level of digitalization applied to our maintenance process within a given time framework. So there are several keys that I think I totally share with Bob and Sebastian. They've been talking about the importance of culture and process, probably in front of technology. So we probably have to go through that path. But then I have to insist on the process, especially we've been working hard in the sense of somehow organizing properly. How do the companies approach the asset management process and systems they need to support the process? So we put a lot of effort to understand where do we need digitalization. So this is not something that we can accomplish once at the same moment in time. So it's something that we have to schedule, and so we have to find out what could be more convenient at this moment in time according to our maturity in our process of asset management. Where are we now, and where should be the most convenient action to transform digitally to make benefit of the existing technologies that we have in the market. So it's a little bit complex, but in order to give clues about these, I'm providing 3 examples that we've been going through. This first one is about how to build a digital criticality analysis. I mean, if we have to do criticality analysis in our assets, and our assets are thousands of assets, 100,000 of assets, and that could be, of course, very difficult and time-consuming. Is there any way, if we benefit of the digital technologies, is there any way that I can do criticality analysis fast and easy in my organization, and have that step finished? To continue with other steps within my reliability management process, maintenance management process. The second one is going to be about, the predictive maintenance that is somehow with all these analytics, predictive analytics possibilities that we have nowadays, is absolutely transforming the way we do things in planning and how we do schedule maintenance tasks and so on, because many of what we call in our standards predetermined maintenance is going to be changing to the condition-based maintenance. So how is that going to impact the way we do things? And is people doing something now, doing a different thing in the future? Things like that. Another clear example is related to asset health indexing. In fact, asset health indexing is becoming an issue for many of our utilities, because many of our utilities start to have assets that are old enough, to think about whether we should renovate them, do a kind of capex or reinvestment in these assets, or should we extend the life of the asset? And in case we have to invest money in the asset, what is the most convenient asset to invest money on? I mean, and somehow to select what and so on. So all these topics are, let's say, could be, focus of our digital transformation. And an example for you to what we've been doing. In fact, I'm starting the strategy process. So basically, what we can see, asset environment is changing dramatically. So what we see, the assets are changing in the sense they are coming to our businesses higher of, in a sense, only record who they are, I mean, and where they are, but they have access to different, for example, computation functionalities. They can interact among each other. They can collaborate. They can send information, things like that. So in a way, our assets, even the system controlling the assets, are changing dramatically. So thinking about that and thinking about where our business wants to be in a certain period of time, what should be our vision for that? And what is the gap that we have if we want to benefit of all, the existing, the environment that we have right now in terms of technology, different assets, different way to communicate, different way to interact, to do things in a different manner. So one way or another, I mean, we have to find our way, and then we have, to set up kind of principle concepts for this mission to be effective, okay? And then do the necessary organizational arrangements, train the people, establish probably or modify existing system and procedures, and then also use new tools, methods, and so on. This is taken from John Dixon Campbell, 95, but this is of course very much in line to what the things we have to do in terms of strategy. In fact, if we talk about maintenance, our main goal as a maintenance, let's say department within a given organization is going to be able to transform suitably, what the business needs in terms of actions that we should carry out on the asset. So the purpose that we have, I mean, our main role is to build the capacity here in our maintenance organization that can easily transform business goals into asset strategy in terms of activities we should perform on the assets, and the different tools that we need to control all that activity level in a way that the business can benefit of our actions. So this is our goal, and so how can we do that in a better way if we use the different digital technologies that we have now? This is the most important thing. So in order to do that, what we're saying is pay attention to your maintenance management model or your asset management model first, because technology is it's lovely. Many times we all like that. Most of us, we are engineers and we really like technology. And then there is a high risk of switching a given technology and adopting a way that then can be very complicated for the business. And whatever we like or we don't like is important probably for us, but not for the business. So concentrate on the business, and on your maintenance management model should be a key point, okay? So the strategy should be made operational in those key aspects of our management model that could be important to reinforce, okay? And so let's pay more attention to process instead of technology implementation initially, okay? So that's the first point. Then I'm going to what Bob and Sebastian was saying. I mean, it is a very important thing to foster new and clear leadership. These kind of things related to culture are extremely important. Identify agents of change, promote digital education and training. So this is going to be a different world. We have to teach people how to move and how to, use all the different tools that we'll have available. And we have to foster this kind of innovation culture. the culture is going to be something like foundations of what we have to do, because all these technologies that we're going to be using now will depend, on soft skill probably, and soft skill depend on culture in the organization. So there will be no unique technology allowing this innovation. We will have to review different possibilities that we may have, especially, that we have many IT big and nice companies providing different tools, but also many industrial vendors doing the same. So we have to be very, very careful with that. And also, technology, we must be careful because, of course, it has to be advanced and everything must be digital, but it has to be very much tested and practical for the business process. Okay, well, probably you heard about this book. This book is about maintenance management. We've been publishing this model since, we published it in 2007, but we've been implemented it in all over the world in many companies. And we have been somehow organizing the steps to follow, so it's kind of process and the framework. So for example, we're saying, okay, you first have to define, if you want to manage maintenance properly, you first have to define your goals, and your KPIs for maintenance, then be able to transform that into priority of the assets. If you have weak points in those important assets, if they have recurrent failures, please get rid of that before designing preventive maintenance plans, and to understand the resources that you may need to accomplish those plans. Then you have to, as a manager, you have to schedule all your activities. Okay, and then activities will be executed, but you as a manager, you will have to check and control execution, and not only for the maintenance department, but also to see how the assets are behaving. Are they following the path that you may expect according to the business plan? Are they costing you what they should cost? Are they having the health that they may have according to how old they are in terms of time they've been with you, and so on? And then you can continue doing that. All this is a maintenance model. You could choose a different one. Definitely in this model, what we do say people, okay, use very interesting tools. For example, failure root cause analysis that we've been, the first presentation today, is extremely important tool when you have important assets and they have recurrent failures. It should be, a standardized tool for a regular company to understand, okay, into this kind of reactive kind of thing. This should be proactive, and this kind of tool must be used on a regular basis on those critical assets that are showing, a recursive, failure problem. But of course, you have to do that. Then, of course, you have to do you use RCM to do this of preventive maintenance design, risk cost optimization to optimize all your resources, things like that. You have different tools at any stage of the business process. The problem is to understand, if I want to improve my business digitally, because I am on an ongoing process, that I'm following, then what should be my next digital tools address to? What should be the next step to follow? That's why we have here phase number 8. This is for improvement. What should be the way to, improve the way I'm doing things? Where should I put my money now to make a better business results? So, well, I call the new maintenance management ecosystem in the sense of different tools that we have now. It's a little bit crazy. We may, of course, I have been putting here inside the cloud different tools that we have that will be, well, maybe, I don't know if did I lose my screen or not? Maybe. Let me make sure I'm sharing. Okay, it's okay. So let me. Okay. So systems somehow that can be, let's say, speak about sending information to the cloud, where you have tools somehow extracting that information, transforming and loading databases. This is going to be probably the way we're going to be acting in the future. But the database has to be configured, okay, according to the purpose of the tool that we're going to be using in our management system. You know, so there is what we call an intelligent asset management system, you know, holding all these different tools that are the one responsible to organize the database for you to be able to have business intelligence. So definitely what we have now is many different apps that are about, as we saw before, root cause failure analysis, but can be also about criticality analysis, RCM, CVN, many different tools that will organize properly your database, that can be different databases, and then you will have gain certain level of intelligence. So, and of course, if you see, I've been adding here different names for you to see that, for example, some IT vendors like Google, they're providing all these tools. They're providing the ETL tools, but also they're providing the tools to store data and even to have it in a streaming or store, and then you have the possibility to process that data. Many one of these tools, they will also even call, you know, different services outside the app, maybe to have, I don't know, a given prediction using a given algorithm of a given tool that they have in the database. So it's going to be complex. So in a way, we have to, but this is going to be like this. It's going to be in the cloud. It's going to be very fast and will be available to your companies everywhere. So if you want, you know, so this is the new ecosystem that we're going to have. So, okay, what we should do is probably think about our maintenance management problem, then select in our asset intelligence tool. If you look, for example, if you see some of these tools in the market, if you go and see SAP tools, or if you go and see Predix or General Electric tools, they all provide this set of apps in these tools, you know, and they build these databases, transforming data that you have all over your business. But the data may be coming from, I don't know, a GIS system, a CMMS, or from embedded monitoring systems that you have inside of your assets. So this is going to be future, and it's happening right now. And again, these apps can also be proprietary of a given provider, but also you have a system where you can develop in Java, for example, your own app, and then have it running it in a given virtual machine in the cloud. So this gives you a lot of possibilities to understand, I mean, to build your own architecture of your system, you know, but I mean, it's something that you have to be thinking carefully, and probably you can do it app by app, in the sense that step by step that you want to digitalize from your system. So for example, we've been doing very curious analysis in terms of criticality analysis using different systems. For example, in this case, we use the geographical information system together with the dispatching system of an electric distribution company, you know, to generate digitally and automatically the criticality analysis, you know, because in fact, if you see how the electrical lines store information, they normally have 6 different layers in this company, in this case. Well, they hold information about where the line, or for example, or the transformer is located. I'm talking mainly here about linear assets of these companies, you know, whether the place is of a public interest, you know, it's in a special protection area or is in a natural park. If you have any railway crossing or main road crossing, it's a populated area. So in fact, you have a lot of information, probably more than 6, 7, 8 different layers that allows you all these different layers. If you build the proper intelligence, this is what I'm doing here. So I'm building here the rules, you know, to tell the system, okay, when am I going to be considering, for example, of high environmental impact? And I can do it that automatically. So if I'm asking about what is the area where we have the asset, whether that is in a high risk, for example, fire zone or not, and whether we have more or less vegetation, things like that may allow me automatically to determine whether it is critical or very high risk, medium risk, low risk in terms of environmental impact. And I can do that with all different factors. Environmental impact is going to be a factor to set up criticality of a given high voltage line, for example. But you may have other factors like, I don't know, safety or, service quality impact, things like that. But you can, all of these factors can be built with intelligence in your system. And for example, this output that you have here gives you the criticality matrix for all these. For example, for this specific line where you have 8,000 assets, they were all scored automatically. And you can see that you may have, I don't know, 4% of the assets only critical. And then you may have also 5% or 6% of the assets semi-critical, but most of the non-critical assets are immediately identified. So you can stress your measures, you know, to these very critical assets, be preventive, but you are proactive with the red, preventive with the, with the yellow, and probably you can, it's not to say to be reactive, but you can say, well, I can get rid of some, can discard some of the maintenance, that I'm doing here in these green ones. So we're working a lot. This is another example, not criticality, but this is about preventive maintenance. We're watching an enormous transformation in the rail sector, because the rail sectors, they have defined here in Europe what they call maintenance responsible units. And the work they're doing, so we have unit developing maintenance, a second one planning maintenance of the fleet, let's say, and a third unit delivering the maintenance. But what is happening now is that, the planning is dramatically changing, because maintenance analytics are absolutely transforming the way we do the plan. And CBM is growing and growing, in a sense that the CBM built up now is giving the notice to the planners about when the fleet is going to need maintenance, and the maintenance will be commissioned automatically, and then the people in the workshop are going to be working, probably using some other digital tools, but the fact is that spare parts are automatically ordered or can be. So the game, as this McKinsey paper is a very interesting one, is saying the game is changing absolutely in the sector. So now, for example, what we're doing is we're developing different algorithms here in the area of ECM2. This is transforming dramatically the way these people in ECM3 schedule maintenance. In a sense, we're building a kind of graphical interfaces here for them to react automatically to the demand of service that is provided by these algorithms, okay? And then you can also build the rules and the intelligence to, to commission the maintenance to the workshop in a very effective and efficient way. So, this number 3, what is talking about scheduling the work, these balls are in fact different trains. The color and the size of the ball give you an idea about the status of the train in terms of failure modes that are with a higher or lower level of risk. So you can, departing from this point, immediately react in the sense of what train is going to be attended, or service first, and so on. So this is really a dramatic transformation, and we are working especially with the high speed trains and with that purpose. And then lately, the last example I'll finish with this example. It's about asset health indexing, which is really to us becoming a very important very important development, because most of the regulators here in Europe are demanding, from different operators of the networks to provide information about the status of the different assets. So one way or another, you have to establish a way to tell the regulator what is the actual health of your asset, okay? So you can build a full digital procedure, and we've been doing this with the gas network here in Spain, also some distribution, but national wide, let's say in the sense of the rail and gas network, we've been working hard at that, and this is digitally implemented right now. And you can use it, you use, of course, information about where the asset is located, because that, of course, can change dramatically his expected life and his health. But the most important thing is also to use monitor, the health modifiers and reliability modifiers that you can use as monitors over the lifetime of the assets. And that can give you a very good understanding of what is the asset now compared to what it should be now. So if I give you an output about these health maps that we're building, this is for the gas network here in Spain, and I'm comparing 24 assets, and then you can see how old the asset is in terms of, how many hours the asset has. The size, each ball is an asset, and the size of the asset is how different is the degradation compared to what it should be expected according to the age. The far the asset from the center is the more degradation the asset has. So you may expect the red balls are far away from the center because they are the older assets, but you can immediately identify those very young assets that are getting, old because they're far away from the center, and also the biggest or the largest the diameter of the ball, the more deteriorated they are according to what we should expect. So this type of visual representation, can give you an immediate understanding of what are the assets needing somehow more help from you, or what are the assets that should be the ones to renovate, or that should be the one to transform the maintenance that we're doing because is not suitable, probably because they are, of course, reaching a very bad health at the moment. In the middle, you have a number of major overhauls that each one of the assets have been going through. So this kind of graphical information in the gas network is absolutely digitalized, and you can compare the assets that you want along the network. If you mix that information with the criticality analysis information, and you add, depreciation of the assets, that is, again, it becomes a digital tool that can be immediately used for reinvestment purposes. Because, what is the health of the asset according to how old the asset is, how depreciated it is, and also how important it is for your business. So if you have this matrix beside accounting information, it will be much more easier for you to take this type of decisions. And then just to finish, just to remember, because I think it's important, because all this, this can be the flavor of the month if we just rely on technology. So my final message is, think about your maintenance model, your maturity in that sense. Think about what should be the more convenient movement to reach a high maturity using these technologies in a given step of your process, okay? And then build your skills and transform your people with proper leadership, to advance appropriately in this world, because definitely we have a lot of challenges. So we have to be very much, vigilant of the possible things that we can do, and then take the right decision. And that's all. Thank you very much.